Hello, this session is getting started.
성채성님.
Chisung Song will speak about decision making with genetics algorithm using DEAP. Please welcome him with applause.
Hello everyone, good afternoon. Thank you for coming to this session. Today, I will talk about decision making with terms of genetic algorithms. Today, it is not a trendy tool like a deep learning, but it is very useful for some cases, especially decision making. Then let's go. Before getting started, let me introduce myself. I'm Chisung Song and I work for Smart Forecast, and I'm interested in various areas for being generalist. In those things, I'm especially interested in three areas: HCI, natural language processing, and data visualization. Contents. Here are 5 topics of this talk. I talk about decision making and genetic algorithms and multi-objective GA for decision making. In the middle, I prepared a little bit practice for this talk. First of all, I will talk about decision making. Every day we make big or small decisions. For example, what to eat for lunch, which smartphone to buy, which way to go. Meanwhile, what was simple decision making before becoming complicated more and more? Let's think about the phones. In the past, we just wanted them for phone calls. So, call connection and prices were really important in the past. However, what about today? When we buy phones today, there are too many things to consider. Does it have a good look, or is it a new model, or is it a popular one, or does it have a good display or long-lasting batteries? Is it good for selfies? Yeah, buying smartphone is so complicated problem now. Well, let's take a look at a question. So easy, right? In fact, it is really difficult question and very easy one at the same time. It sounds like a paradox to you, but yes, it does. Because we have computers. For difficult questions, we rely on them. One most effective way to use computers is to make them learn and find the answers on their own. We call it machine learning. Specifically, one of the most representative machine learning technique is deep learning. Definitely, deep learning is a very useful tool, but there is a fatal problem. What is that? The problem is that it is so difficult to understand for programmers, and it also requires various background knowledge and skills, like programming and statistics and mathematics. That's why today I will introduce another tool, easier and more useful one for decision making. It is genetic algorithms. I think everyone here is familiar with the word algorithm. Then, what is genetic? For that, we are going to take a look at genetics. Human body consists of cells and the chromosomes in the cells we have. We have genes. Genes are basic introductions for building an organism. Genes are located in chromosomes and as a sequencer from. Each gene represents a specific trait of the organism. For example, eye color or blood type. Now, let's look into the main topic of this session, GA, the genetic algorithms. To help your understanding of GA, here is a famous story about evolution. There are giraffes in the savannah. Originally, the neck of giraffes were not that long. Occasionally, however, there were exceptional giraffes having necks just a bit longer than the others, like this. With their longer necks, they survived the others by winning in the struggle for existence. Generation to generation, they inherited the trait to their offspring. That's why giraffes we know now have long necks. This is one of the famous hypotheses of evolution theory, survival of the fittest. In other words, the fittest one which is more suitable for tough environment to survive. This is the key concept of genetic algorithms. In Korean, 적자생존. As I just said, GA is a model of machine learning, which derives its behavior from a metaphor of the process of evolution in nature. Natural selection and genetic inheritance by Darwin is that. Originally, it developed by John Holland, and its characteristic, because of its heuristic, it generates useful solution to optimization and search problem. So it's very useful for decision making. And it is usually applied on data science or robot control or TSP algorithm. This is basic structure of GA. Each individual is coded as a finite length vector. Individual which is represented to a given problem, we can call them chromosomes. This is chromosomes, and instead of a set of variable and limitless individuals in nature, GA operates a set of chromosomes. This is called the population. In other words, GA is operated with multiple number of individuals. A population of individuals are maintained within search space for a GA. Let's find out more GA operators. For basic GA model, there are three basic operators: a selection operator, crossover operator, and mutation operator. Let's take a look. Selection, first of all, the selection operator. Selection operator gives preference to better individuals, allowing them to pass on their genes to the generation. The goodness of each individual depends on its fitness. Fitness may be determined by an objective function or by subjective judgment. And the next one is crossover operator. Crossover operator process of taking more than one parent and producing offspring from them. By recombining portion of good individuals, the GA is more likely to create a better individual. Various methods for combining the parents. There are various methods for combining the parents, like one-point crossover or edge recombination. Like this figure, the individual of the parents are crossover and make a new offspring inherited those parents. The last one is mutation. Mutation operator which crossover that I said before building crossover that I said before building offsprings by copying partially and traits of offsprings are inherited by parents. With this crossover, offsprings can get good trait for each parent. But there is a problem in that. They can't get trait from their parents. However, this problem can be solved by this operator, the mutation. With mutation, offspring can have traits which their parents don't have. If parents doesn't have this trait, by mutation, it can be possible. If these star traits are good for survival, then the population is stronger than the tough environment. Here is the outline of basic GA. GA is usually operated in this process. First, randomly initialized population. The T is the generation. At that time, the T is 0. And evaluate fitness of population. Evaluated them and select parents from population, which is good individual, and perform crossover on parent creating population. In that time, T plus 1 because next generation for the crossover. And next, perform mutation of population. Evaluate the fitness of and next evaluate fitness of population. And repeat those things and until the best individual is good enough. Then now let's apply this concept into practice. We need a certain interface to build the GA model. Here is the interface called DEAP. Let me introduce the tool which I use today for GA, DEAP, the distributed evolutionary algorithm in Python. DEAP is novel evolutionary computation framework for rapid prototyping and testing of ideas. In addition, DEAP basically provides various useful tools. Like I said before, operators. Also, you can customize it based on your situation. It is a little bit hard to start at first because the interface is unique. But doing some tutorials on the official website, it becomes easy to use. There are two core architectures for DEAP. First one is creator. Creator is meta factory, allowing the runtime creation of classes via both inheritance and composition. Attributes, both data and functions, can be dynamically added to existing classes in order to create user-specific new types. By using this, the creation of individuals and populations from any data structure, like list, set, dictionary, tree, and so on. Next core architecture of DEAP is toolbox. It is simply just think about toolbox. There is a container for the tools, which is, I said before, operators, and that the user want to use. Manually populated by the user with selection tools. Then let's try this. It is just simple practice. For this, I'm gonna use Jupyter Notebook. So where is Here, those are my practice code. First one is basic genetic algorithm. Here are 5 numbers. When added, we get 100, like 100, 0, 0, 0, 0. And second one is like those. And then we get some of these are becomes 100. Then these 5 numbers in combination make 100 in sums. Then let's find those combination of any other combination by using GA. First of all, you should setting up the things. First of all, import DEAP, and you can use creator and create the individuals and population. So in the code we said like that, creator and create the fitness mean and base fitness and weight. That means those line means create a new class named fitness mean. That is what I define name, and inheriting from base fitness with attribute weight -1 and -1 tuple table. Yeah. This weight means minimum get a minimum problem. And next one is create individual. That is inheriting from list and using the individuals. The fitness is use creator fitness mean. Those functions. Yeah. And then we can set up the toolbox. The toolbox is, as just I said, a container for the tools that the user wants to use. So make a toolbox and for those problems we can use random. We should to get a random number for getting sum of 100. So we use those functions, random int. That it can be one of the, we can get one of genes for the GA. Inheriting with random int, we can make a attributable function using this toolbox, just register method. Then it is same function, those things, like that. And then we should loop that for making an individual. So just those lines means just to use those lines and make an individual, and those lines to make population. Then we just make individual like those things. There is 5 numbers of list by random number, and we can make a toolbox. We can make population using that. So let's make an evaluation function for those GA. We can easily think about these things. The sum error function. That means that returns 100 and error of sum of individuals and 10 100. So we use like this. There is sample individuals, and that time the sum error is that. There is quite different for our objective. So we can use this. We can use DEAP. We can the optimal answers for that. So these are register the evaluate function for we defined before, and register other operators for GA. That mate is for crossover operators, and mutate function for mutation, and select function for selection operators. And we can get 10 of individuals population, which is combining 10 of individuals, 100 of individuals, like that. And that Hall of Fame is we use Hall of Fame in order to keep tracks of the best individual to appear in the evolution. It just keep it even in the case in existing is, yeah. And we register the statistics tools, and we just run with this DEAP. So it's fine. Yeah. So the sum of individual are becoming 100. Yeah. So we can select we want to get that. The sum of these individual is 100, right? So far we use GA for getting optimal solution for just one objective function. Then how about multiple objective problem? Let's see multiple objective GA. This figure shows which fruit can be evaluated in the 2 points of view, the tasty and easy to eat. You can think each point of view is an objective function which is made for a problem. Multi-objective problems are more complex than the others we handled before. Let's look at this figure. Through this figure, pineapples are one of the delicious fruits. But if you only consider that, you can select pineapples as a dessert for lunch. But if you think how difficult to eat that, that is not a good choice. Maybe peach is selected as a dessert for lunch because it's both tasty and easy to eat. Then how can you solve these problems? Don't worry, we have multi-objective GA. In this session, we use NSGA. That is a second version of non-deterministic sorting algorithm and one of the most popular multi-objective algorithm. These are decision space and objective space. Decision space is the set of our choice in the real world, and objective space is the evaluated values using objective function. In this figure, there are two objective functions. And there are no enough time, so I skip the problem practice. So here is a short story of this practice. Tomorrow, Simpson is going on a business trip to Korea. It is his first time to visit Korea. His Korean colleague recommended the attractions. Surprisingly, it was 75 spots with recommended scores. But he is so busy and he has only 1 day for free time. He wants to go to only 5 spots based on short journey and high recommended scores. How he can make an optimal decision? There is a second practice, and I prepare data from Seoul data portal, and we just load this data and we get those things with the street for attraction and geo data and scores, recommended scores. First of all, I visualize them on the map using Folium. Maybe networks are not that good. And second things, next, we can apply genetic algorithm the data. The practice I said before is same process, but different one is the weight. At the code At the practice I showed before is just one weight, but it is multi-objective general algorithm, and it has two weights. -1 is for minimum, 1 is for maximum. That is because we should minimize the distance and maximize the recommended score. So we those things and make evaluation function like first of all, we can create tours by individuals. A tour is created by individual, and it is geodata, and we got the distance from those things, and we get total distance of that tour, and we can plot tour like those things, and we can visualize that like that. is 뭐 함안길, 해만길, 해맞이길, 뭐 능동로, 대학로 street, scores 99. Using those things, we can evaluate function like this function. First objective function is total distance, minimize total distance, and second one is maximize total score of recommending point. And this penalty is for because of genetic algorithms crossover. And evaluate this individual. Turns out this tuple, these two evaluated value, and we can got the population and learning them. Then this code is shared, so you can see in the your free time. Yeah. So when the learning is over, then we should make a decision. There are fronts of the result of the learning, and it is suggestion of the good solution. It's weird. And we get the solution. So there are many choices for those problems. We can think about it can be short and short. sorry. Maybe it. Maybe it's going wrong. 뭐지? Maybe this code going wrong. If we get right answers, then there is many solutions to choice. So one is the long distance, but one solution can be short distance and high scores, or any other thing, and any other solution can be long distance and short distance and short low scores. Yeah. If code, I don't know what it returns wrong result, but yeah. I will fix and share it. Yeah. So yeah. There are good reference of this genetic algorithm. It is DEAP official docs and Louis Marty's evolutionary computation course reference. And thank you for listening this session. Thank you.
Thank you for Chisung Song. We will have a Q&A form now on. Please come to the mic if you have a question. 질문 있으신 분은 마이크 앞으로 나와서 질문하시면 됩니다.
네, 감사합니다.
So there are so many kinds, there have been so many kinds of prompts in.
Yeah.
So how to choose the best solution from the kind of prompts?
It is like that. If you want to eat more tasty one, then you can eat pineapple. It's okay, but that's on your choice. Yeah.
What's your choice?
Yeah. My choice is middle of that. Yeah. like cherries. Yeah. Yeah. Thank you.
Familiar with a lot of methods that are used for determining where you cross over for genetic algorithms, but I'm curious, how do you prevent getting stuck in a local maxima as opposed to when you're trying to converge, trying to local maxima?
You mean
When you're trying to find an optimal solution at the global maxima,
Yeah.
how do you prevent, is there a method to do something like maybe simulated annealing where increase where you're maybe at different times during the process trying to cross over different places
Yeah.
and then restrict it to a smaller subset later on?
Have you ever used the GA?
I'm familiar with the concept, but I don't know a lot about how like the crossover point is determined.
For preventing the local in the GA, we can say it local optima because GA for find the optimal solution. So it is we can use mutation because that I think it is the answer for your question. With only crossover, the offsprings can get good traits of this its parent, only parent, but it can be not the global optimal solution.
Right.
So using the mutation operator, then it can be more various. You can get various ways.
I understand. All right, thank you. That answers my question, actually.
Yeah.
Thank you.
Thank you very much for the talk. Very interesting. Because I'm gonna have some friends from the US, and so that will be really interesting. The result initially. So I have two questions for you. The first one is can we just rate some functions? Like you just showed two functions, right?
Two functions? What?
The one like the distance and then
Yeah.
forward.
Yeah.
So can we add them more like in a multiple
Yeah.
functions, right?
It can be possible if your situation you need more things to consider, then you can use many ways for the multi-objective GA. Yeah.
Variables. My second question is about that. Can we rate some functions? To me, it looks like a regression analysis. So to me, when we just determine some spots to visit, then you used just in the figure you said, you just choose in the middle first. We have our evaluated subjective measurement. So can we rate some particular functions?
I understand you said it can be subjective. It can be more subjective for the situation, but maybe I will second practice can be because it is the score is just my I scoring them. So
That's just a variable, just a data, right?
yeah.
So we have something in our mind and we want to focus on some particular functions that I think that we can do that, but I just wonder whether GA just has that on its own.
Yeah.
Just very curious.
Could you talk more slowly? Yeah. Thank you. Talk in Korean. Yeah.
Please give Song Chisung with applause for the great session.